There is a light in the early universe that should not be there. It is small, it is red, and it is scattered across the oldest sky we have ever seen, in numbers no theory predicted and no astronomer asked for. When the James Webb Space Telescope first turned its golden mirror towards the dawn of time, it expected to find darkness slowly giving way to the first faint galaxies. Instead, it found thousands of tiny crimson points, burning steadily where almost nothing should yet be burning. They appeared barely 600 million years after the Big Bang, a cosmic eye blink after creation. And then, as the universe aged, they quietly vanished. For years, no one could say what they were. Some scientists whispered that these little red dots had broken cosmology itself. Now Webb has captured the deepest look ever taken at one of them. And the answer may be far stranger than the question. If discoveries that bend the rules of the universe are the reason you're here, take a second to subscribe before we go any further, because this is one of those stories that only gets bigger the deeper we dig. Now let's go back to the beginning, to understand why these red dots terrify the people who study them. For most of the last century, we believed we understood how the universe grew up. The story was slow, patient, and orderly. After the Big Bang, the cosmos was a smooth, featureless fog of hydrogen and helium, expanding and cooling in the dark. There were no stars, no galaxies, no light at all, beyond the fading afterglow of creation. And then gravity did what gravity always does. Over hundreds of millions of years, that gas began to clump, to collapse, to ignite. The first stars flickered to life and gathered into the first small galaxies. Those galaxies merged and grew, and deep at their centers, black holes formed. First modest ones, then larger ones, feeding gradually over billions of years until a rare few swelled into the supermassive monsters we find at the hearts of galaxies today. The black hole at the center of our own Milky Way is about 4 million times the mass of the Sun. Building something that enormous, we assumed, takes almost the entire age of the universe. It is a process measured in eons, not in moments. Think of it like growing an ancient redwood. You don't get a 1,000-year-old tree overnight. You get a seed, then a sapling, then slow century after slow century of patient growth, ring by ring, until something towering finally stands where there was once only soil. That was the rule. That was the timeline every textbook trusted. The comfortable story we told ourselves about how a universe assembles its giants. It was elegant. It was logical. And James Webb was about to take that story and quietly set it on fire. Because Webb doesn't just see distant objects, it sees ancient ones. This is the part that never stops being astonishing. Light from the early universe has traveled for more than 13 billion years to reach us, which means every faint smudge in these images is not a snapshot of the present. It is a photograph of the deep past, a fossil made of light, showing the cosmos exactly as it looked when it was young. To look far away is to look backward in time. And in those photographs from the dawn of everything, beginning in 2022, astronomers kept noticing the same uninvited guests. Compact, intensely red, far too bright and far too developed for their age. The community named them, almost affectionately, the little red dots. But the affection did not last. Because when scientists measured them, the numbers refused to make sense. If these dots were galaxies, they were impossibly massive. Fully grown adults in a universe that should have held only newborns. They seemed to contain more mature starlight than the cosmos had time to produce. It was as if you developed a roll of film from a child's first birthday party and found a grown man already standing in the corner of every frame. One explanation after another was proposed, and one after another it cracked. That is the precise moment a discovery stops being exciting and starts being dangerous. When a thing exists that your best science says cannot exist, you are left with only two possibilities. Either the thing is wrong, or your science is, and the little red dots were not going away. So astronomers did what good detectives do. They stopped guessing and went hunting for the single deepest, clearest piece of evidence they could find. The breakthrough came from one lucky dot. A team led by Vasily Kokorev at the University of Texas at Austin focused on an object catalogued as Glimpse 17,775, sitting far behind a massive cluster of galaxies called Abell S1063. And that cluster did something extraordinary. Its gravity is so immense that it bends the very fabric of space around it, acting like a natural magnifying glass, a cosmic lens predicted by Albert Einstein more than a century ago, when he realized that mass itself could warp space and steer the path of light. Nature had built a telescope larger than any we could ever launch, and Webb simply looked through it. Through that lens, it captured the deepest spectrum ever taken of a little red dot. And here is why that matters. A spectrum is so much more than a picture. It is the fingerprint of light. Split a beam into its component colors and you can read, written in the gaps and spikes of that rainbow, what an object is made of, how hot it is, how fast it is moving, and what is happening deep inside it. This is how we know the composition of stars we will never visit and the speed of galaxies we will never reach. It is the closest thing astronomy has to a confession. And the confession this fingerprint gave us changed everything. Hidden inside that small red glow, the evidence pointed to a supermassive black hole, already grown to somewhere between 100,000 and 10 million times the mass of our Sun, wrapped in a thick, churning cocoon of dense, glowing gas. Gas moving at over 1 million kilometers an hour. Not a galaxy full of stars. Something new. Something the scientists are now calling a black hole star. Sit with that phrase for a moment, because it is a contradiction made real. A black hole star is not a star in the way the Sun is a star. There is no fusion at its core, no nuclear fire holding it together. It is the opposite, a ravenous, growing black hole, buried so deeply inside a shell of hot, partially glowing gas that the entire object radiates from the outside like a single, enormous sun. The black hole feeds, and as it feeds, it superheats the gas around it, and that gas reprocesses the light pouring out from the edge of the abyss, smearing it into the strange red signature Webb keeps finding again and again across the early sky. From the outside, you would never guess a monster sits at the core. You would see only a small, red, deceptively gentle point of light, a wolf wrapped in the softest possible disguise. And that disguise is exactly why these objects fooled us for years. We were looking at predators and seeing candles. If your sense of the universe just shifted a little, you're not alone. And a like on this video genuinely helps more curious people find this story. Now let's get to the part that makes this more than a curiosity. Let's talk about why it could rewrite the beginning of everything. For decades, one of the deepest puzzles in all of astronomy has been a simple, maddening question. How did the universe build supermassive black holes so fast? We see them fully formed when the cosmos was less than 1 billion years old. Gravitational giants that, by every model we have, should not have had nearly enough time to grow. It is like walking into a delivery room and finding a fully grown adult who was born 10 minutes ago. The math doesn't just strain, it snaps. Black hole stars may finally offer a way out. If these objects are the early, hidden growth phase of supermassive black holes feeding furiously, voraciously inside their gas cocoons during the universe's first chapter, then they could be the missing link we have been chasing for a generation. The seed stage. The answer to how the monsters got so big so quickly. They would explain the unexplainable, and the implications cascade outward from there. Rewrite how the first black holes formed, and you rewrite how the first galaxies took shape around them. Because the two are bound together in a cosmic dance we are only beginning to understand. You rewrite the timeline of the early universe. the conditions that, billions of years later, would allow gas and dust to settle into stars, into planets, into worlds, and on at least one of those worlds, into us. Some astronomers are calling this potentially the most important thing James Webb has discovered since the existence of dark energy was confirmed in 1998. In a field where bold claims are rare and carefully earned, where careers are made on caution, that is not a sentence anyone says lightly. These tiny red dots, easy to mistake for cosmic dust, may turn out to be a doorway into the very first moments when the universe began building the giants that shaped all that followed. But here is the part that keeps the mystery alive, the detail that no one can fully explain, even now, even with the deepest spectrum we have ever taken. These little red dots do not last. They blaze across the early universe for a few 100 million years, and then, somewhere before the cosmos reaches 2 billion years of age, they disappear. They simply stop showing up in the data. An entire population of objects scattered in their thousands across the young sky, and then gone. Where do they go? One idea is that the black hole star is a phase, not a permanent state. A violent, short-lived growth spurt that eventually burns through its own cocoon, blows away the gas that disguised it, and transforms into the kind of ordinary supermassive black hole we recognize at the centers of galaxies today, no longer wearing its red mask, simply hiding in plain sight. The dot doesn't vanish. It grows up. Another clue arrived from a completely different telescope. NASA's Chandra X-ray Observatory spotted a rare red dot that glows in X-rays, an object that may be the bridge between these strange black hole stars and the familiar black holes that come after them. A single thread, linking the impossible to the ordinary. A footprint left behind in the transition. And yet, even now, the scientists are careful with their words. This is the strongest evidence yet, but the case is still being built, dot by dot, spectrum by spectrum. The little red dots have not finished surprising us. With every deeper look, they seem to offer one more secret and pose one more question. We are not at the end of this mystery. We may only be at the end of the beginning. So where does that leave us, standing here at the edge of what we know? It leaves us looking up at thousands of faint red lights scattered across the oldest sky we will ever see, each one a furnace of gravity, wearing the mask of a gentle star. Each one a clue to how the universe assembled its giants in the dark, long before there were planets, before there were oceans, before there was a single living thing anywhere to wonder about any of it. For 13 billion years, that light traveled toward a telescope that did not yet exist, built by a species that had only just learned to look up. And when it finally arrived, folded into the faint red glow of a dot smaller than a pixel, it carried a message we are only now beginning to read. That the cosmos is older, stranger, and far more creative than our equations ever dared to imagine. We thought we knew the story of the beginning. Webb is quietly telling us we may have only read the cover. The universe didn't break the rules. We just hadn't learned them yet. If this story rearranged something in your mind the way it did in mine, do me a favor before you go. Hit that like button. It genuinely helps this channel reach more people who feel the same pull towards the unknown. Subscribe, so the next discovery finds you the moment it breaks. And here's the question I want you to answer down in the comments. If these little red dots really are black hole stars, monsters disguised as gentle light, what else do you think is out there right now, hiding in plain sight, waiting for us to finally understand what we're looking at? Tell me what you believe, because somewhere out there, in light that left before the Earth was even born, the answer is already on its way to us. We just have to keep watching.